This video is on solving compound inequalities. The word compound here, let me underline that, simply indicates, as it often does in math, that you've got something extra going on. So, there are two types of compound inequalities. One where you shade between two numbers, and two where the shading is split into two pieces. So I'm going to show you the shade between two numbers. This is when x is between two numbers, like x is between -1 and 4. The split shading, and this is the and type. So x is bigger than -1 and it's smaller than 4. So it's both things at the same time. With the split shading, I'll use -1 and 4 again. With the split shading, x is either smaller than -1 or it's bigger than 4. So x is either over here or it's over here. So we have two types, shade between and the split shading. Now there's one rule. Like with most solving, you just want to make sure you do the same thing to both sides. Now I'm going to change this both sides part because sometimes you have more than two sides, which I realize is a strange thing to say. So do the same thing to all parts. You'll understand that better in a minute. Now don't forget, we have this little caveat with solving inequalities. If you multiply or divide by a negative, in the process of solving, then you have to flip the inequality. You must flip or reverse the inequality symbol. So a less than becomes a greater than, and a greater than becomes a less than. All right, let's practice. First example. We're going to solve and graph 2 is less than or equal to x plus 1, which is less than 5. Notice that we have an expression x plus 1 trapped between a smaller number and a bigger number. Because this inequality has a left, a middle, and a right, it's called a three-part inequality. And this is the and case. You'll see that in just a second. Well, the first thing we're going to do is we're going to draw dividing lines at our inequality symbols, just like we did in the previous video, except this time we have two inequalities in one problem. Now our goal is to isolate x, so we need to subtract 1 in order to get x by itself. Why does that work? Because 1 minus 1 is 0. Now if I subtract 1 from the middle part, I also have to subtract 1 from the left side and from the right side. That's what I meant up here when I said all parts, right up here. All right, 2 minus 1 is 1. The less than or equal to is still there. X is now by itself. The 1 in the middle is gone. The less than is still there, and 5 minus 1 is 4. This is a three-part inequality. X is trapped between the numbers 1 and 4. So we could say x is between 1 and 4. Now notice that the 1 has an or equal to with it, so the 1 is included, but the 4 does not have an or equal to with it, so the 4 is excluded. Let's go ahead and graph our solution. The numbers we care about are +1 and +4. I'm going to go ahead and put a 0 over here on the left. We know that 1 is included, so we do a closed circle. 4 is excluded, so we do an open circle. And we know that x is between 1 and 4. So this is the AND type of problem because x is bigger than 1 and it's smaller than 4 at the same time. Next example. We're going to solve and graph -4 is less than 2x minus 5, which is less than 7. Notice again, we have a 3-part inequality. This is the AND type again. We're going to draw lines at our inequalities. Remember, we're trying to get x by itself. So this is a 2-step problem here. We need to get x by itself, so we're going to move the 5 first by adding 5. Why does that work? That works because -5 plus 5 is 0. That leaves 2x by itself. We have, let's see, we have to add 5 here on the left. We also have to add 5 here on the right. -4 plus 5 is 1, strictly less than 2x. The 5's gone in the middle, strictly less than 12. And now, if I want to isolate x, I have to get the 2 to divide out. Because why? Because 2 divided by 2 makes 1. If I divide in the middle by 2, I have to divide on the left and on the right by 2. So I have 1/2 is less than x is less than 12 divided by 2 is 6. We'll go ahead and graph that. Let's see, put a 0 here. I'm going to put a 1 here, and then 2, 3, 4, 5, 6 here. Now 1/2 is the same as 0.5, so it's between 0 and 1. I'm going to put it right there. So I'll label that 1/2. 6 is here. Notice on both ends we have open circles because we don't have any or equal to's with our inequality. And then x is between those two numbers. So we shade between those two numbers. This is an AND because x is bigger than 1/2 and simultaneously smaller than 6. All right, next example. Five is less than or equal to 7 minus x, which is less than 10. We have a 3-part inequality again. Draw lines at the inequalities. Remember, you're isolating x, so the first thing we're going to do is subtract 7. 7 minus 7 is 0. That leaves -x by itself. That's what we want so far. Now if I subtract 7 from the middle, I have to subtract it from left and right as well. 5 minus 7 is -2, less than or equal to -x in the middle, which is less than 10 minus 7, or 3 on the right. Now I'm still not done isolating, because remember that negative means there's a -1 attached to the x. The only number we want in front of x is invisible +1. So we're going to divide by -1 on all 3 parts. We're dividing by a negative. So when you divide by a negative and you're working an inequality, you have to remember to flip those inequalities over. -2 divided by -1 is +2. Flip over the inequality, positive x in the middle, flip over the inequality. 3 divided by -1 is -3. Now notice this three-part inequality has greater thans in it, so we want to rotate this inequality. So basically you're just kind of like spinning it around, because when you write a three-part inequality, you want your inequalities to be less thans. So you're going to put the smaller number on the left. -3 is the smaller number. Less than, x is still in the middle, which is less than or equal to 2. Now look back and forth for a second and notice that in our original answer, the little arrowhead is pointing at the -3. When we rotate it, the little arrowhead is still pointing at the -3. On this side, the inequality is pointing at the x. When we rotate it, notice the inequality is still pointing at the x. Now we're going to graph that solution. We need an open circle at -3. We need a closed circle at +2, and x is in the middle. So my x is between -3 and 2, excluding the -3, but including the 2. All right, three-part inequalities can be presented to you another way. So we're going to do one more example of a three-parter. 2x plus 3 is greater than -1, and 2x plus 3 is less than 5. So what they've done here is they've split the three-part inequality and just made two entirely separate inequalities. And you have to solve them both. So draw your lines at your inequality symbol and then isolate your variable. Since 3 is being added, I'm going to take it away from both sides. That leaves 2x by itself, greater than -1 minus 3, which is -4. And since 2 divided by 2 is 1, I'm going to divide both sides by 2 to get x by itself greater than -2. Okay, that's part of my answer. And don't lose that. Now the other inequality, I solve the same way. I just get different numbers. So I'm subtracting 3 from both sides, leaving 2x by itself is less than 5 minus 3, which is 2. Then I divide both sides by 2 to get x by itself, and that's x less than 1. So x is greater than -2 and x is less than 1. Let's graph that. -2 is here, and I want to be bigger than -2. That means shade to the right. X equal 1, I'll put it right over here, not included, and I need x to be less than 1. Notice the two arrows are coming towards each other. That means I'm trapped between -2 and 1. To write that answer as a three-part inequality, you would put the -2 first, then a less than, then the x, then a less than, and then the 1. Now notice, this inequality that I'm pointing at right here is pointing at the -2, and so is this one. This inequality is pointing at the x, and so is this one. So there's my answer. That's the best way to write it right there. Our last three examples are going to be of the OR type. This is the split shading type of problem. Our first example of the last three is 3x plus 1 is less than -2, or 3x plus 1 is greater than 7. So basically, one of two things will be true, either this one on the left or this one on the right. So we solve them just like we always solve things. I'm going to subtract 1 from both sides because 1 minus 1 is 0, less than negative 2 minus 1 is negative 3. And then in this, now I need to, divide by 3 on both sides. Notice I'm dividing by a positive, so I don't do any flipping. X is less than negative 1. That's part of my answer. Or, I solve the other one the same way. I'm subtracting 1 from both sides. That leaves 3x by itself is greater than 6. Then I divide both sides by 3. Because 3 divided by 3 is 1, and I get x is greater than 6 divided by 3, which is 2. So either x is less than negative 1 or x is greater than 2. Let's draw a graph and see why we can't write this as a three-part inequality. Negative 1 is here, positive 2 is here. Neither of negative 1 or 2 happens to be included in our solution, so they both get open circles. Now, this first inequality says x is less than negative 1. That's numbers smaller than negative 1. The second inequality says x is greater than 2, and that's numbers to the right of 2. So you can see that x can't simultaneously be in both positions. Either x is over here on the left, or x is over here on the right. And that's what creates the split shading. Next example. X plus 2 is less than or equal to negative 6, or x plus 2 is greater than or equal to positive 6. I'm going to draw lines at my inequalities, and I'm going to solve. Subtract 2 from both sides, and you get x is less than or equal to negative 8. Or, subtracting 2 from both sides, you get x is greater than or equal to 4. Now, I should have crossed off 2 minus 2 is 0, 2 minus 2 is 0. Let's draw a graph of these two parts of the solution. Negative 8 is way over here on the left. Positive 4 is going to be way over here somewhere on the right. These both happen to have or equal to's. So both of these are, both of these are going to get the colored in circles. But x less than negative 8 is left. X greater than 4 is right. So x is here or x is there. Our last example. Negative 2x minus 3 is less than negative 7, or negative 3x minus 1 is greater than or equal to 5. Alright, notice these two expressions on the left look different. That's fine. Just work with what you're given. I'm going to add 3 to both sides of this first inequality. Negative 3 plus 3 is 0, so negative 2x is by itself, less than negative 7 plus 3 is negative 4. Now I'm going to divide by negative 2 because negative 2 divided by negative 2 makes positive 1. I'm dividing by negative. I gotta flip that thing. So now it's a greater than. Negative 4 divided by negative 2 is positive 2. Or, second part of the inequality, I'm going to add 1 to both sides because negative 1 plus 1 is 0. So negative 3x is by itself, greater than or equal to 5 plus 1 is 6. Dividing both sides by negative 3 That means I have to flip the inequality, and I get 1x is less than or equal to -2. So either x is bigger than 2 or smaller than -2. Now notice 2, the positive 2 does not have an or equal to with it, so that's an open circle. The -2 does have an or equal to with it, so that's a colored in circle. Greater than 2 is to the right, less than -2 is to the left. And that's the graph of that solution. Okay, so we've just learned to solve what are called compound inequalities, and that's because they just have a little bit more to them than a normal inequality. Thank you for watching.